In this video, I'm going to discuss a few properties of absolute values. These properties are going to be the most basic properties of absolute values, so if you're just starting with absolute values, this might be the video for you. The first property I want to talk about is the absolute value of any number always has to be greater than or equal to 0. If you think about absolute value on a number line, say we have 0 right here, -5, -10, 5, and 10, something like this. We want to think about absolute value always as a distance because absolute value is our distance from 0. So if we look at -5 here, the distance from 0 is actually 5 units because really you have -1, -2, -3, -4, and you're hopping 1, 2, 3, 4, 5 units. So if you took the absolute value of -5, it's talking about how far away is -5 from 0. Well, that's 5 units. But if it's talking about how far away something is, like a distance from 0, the absolute value can never be negative because you can't have a negative distance. It could be equal to 0 though, because you could have the absolute value of 0. The absolute value of 0 is equal to 0 because you don't move anywhere. 0 is right at 0. There's no distance from 0 at that point. So the first property is really that just any absolute value always has to be either positive or equal to 0. All right, this next property that you may need to use at some point is that the absolute value of a negative number will be equal to the absolute value of that same number but positive. So if you think about that number line that we just talked about, and we have 1, 2, 3, 4, -5, 1, 2, 3, 4, and +5. We discussed that -5 had an absolute value of 5 because it's 5 units away. If you count each of the units, 1, 2, 3, 4, 5. -5 is 5 units away from 5. But then let's go ahead and talk about the absolute value of +5. That -5 represents that negative a, and 5 represents our a. So we're just talking about 5, both positive and negative. We could be talking about 3, -3 and +3. The property still holds true. So again, if we look at that +5, we're going up 1 unit, 2 units, 3 units, 4 units, 5 units. That is also equal to +5. You will always notice that even if you extended this number line and you talked about maybe -10 and +10, -10 and +10, their absolute values will also be equal to 10. So if you take the absolute value of -10, you get +10. The absolute value of +10 also equals +10. So no matter what two numbers you pick, they have to be opposite numbers. So in this case, -10, +10, or -5 and +5, they will always be equal to the same number. I don't like to say it this way, but if you think about it as the absolute value makes the number positive, so the absolute value of -5 goes to +5, +5 just stays +5, then you can kind of see how they're always going to be equal to the same number. This second property states that if you have any two numbers being multiplied together within the absolute value, that's going to be equal to both of those numbers in separate absolute values being multiplied together. So let's look at an example. If we have a -2 times 6 inside the absolute value, we can actually do that multiplication first to get -12. And then if we take the absolute value of -12, we get +12. This represents the absolute value of AB, the left-hand side. Now let's take a look at -2, the absolute value of -2, times the absolute value of 6. This is that A times B. So the -2 and 6 were first inside the absolute value, but now we've separated them. So if we take the absolute value of -2, we get +2. And if we take the absolute value of 6, we get +6. 2 times 6 also equals 12. So these are equal to the same number. You won't always have just numbers inside the absolute values. Sometimes you'll have something that looks like -2x. And then by using this property, we can split that up in the absolute value of -2 times the absolute value of x. So that's just one way that you can apply this property. Looking at this next property, this is kind of very similar to the last property we looked at with the multiplication, except now we're dividing. So in this case, if we were dividing the 6 and -2 instead, we could go ahead and do that division first to get the absolute value of -3, which equals 3. Again, that represents that just whole absolute value side, the left-hand side there. But then if we split up the absolute value and do the absolute value of 6 divided by the absolute value of -2, we can evaluate those absolute values separately. So we would have the absolute value of 6, which is 6, the absolute value of 2, which is 2, 6 divided by 2 is 3. So yes, these do equal the same thing. And just like the last one, you could apply this to something like x over -2. If you had that inside the absolute value, you could split that up as the absolute value of x over the absolute value of -2. The one thing I do want to touch upon is this b not equal to 0. Anytime you have a denominator, notice that b is our denominator. It can't be equal to 0 because that means you're dividing by 0, and we can't divide by 0, which is why this b value can never be equal to 0. All right, to just go ahead and sum up the properties of absolute values that we used, if you have any absolute value, just know that it always has to be either greater than 0 or equal to 0 because we're talking about distance from 0, so distance can't be negative. And then if you're either multiplying or dividing two numbers inside the absolute value, you can split those up into two separate absolute values. So you're either multiplying the two separate absolute values or dividing the two absolute values. And those are a few properties of absolute values.